Very good evening to all. I'm Bharat from IERS, and today's lecture will be on GPS concept. In fact, we can call it GNSS concepts also, and mobile mapping and applications in the urban utility mapping. So this is the broad topic. It will be there. So I will be covering something on the GNSS concept, something on the mobile mapping, hardware, software, some whatever the concerns, hardware software concerns, and finally how we can use to the urban utility mapping. That is the basic objective we will be looking into it. Okay, coming to the urban utilities means it includes a lot of things. It can be either a water supply system or a electricity supply system or a stormwater drainage system. uh, it can include any of them. Basically, these are nothing but the networks. So it will have some starting point, ending point. See, basically, if you look this slide, if we see this is an electricity network, at the end we do have some households, we do have some business commercial establishment. This will get linked to the electricity distribution. Then from the distribution, distribution comes from the transmission, transmission comes from the generation. So it's a huge network. So once you come to the end, we need up to the street lights, electricity connections. We need a lot of information. So some information we can get from the high resolution data, but basically for the urban utilities, GPS has a lot of utility. As if you look any town, we do have thousands of street poles. If you have to map all the street poles, we can't locate in the high resolution data. We have to go for the GPS map. So what exactly is the GPS? So it is a very common term we are using every day, and it has become wherever we are going, we are trying to take our directions from place to place. All these things we are getting from the GPS. So, but there are some concerns which we should look into it. What type of GPS equipment we should use it, and depends on what scale of our mapping and all. So basically, I have just shown you a small picture. In GPS, we are calling this American constellation as called a TASTAR. So it has around 24 satellites, and in 6 planes, and in each one 4 satellites like this. So this is the thing what is going to happen in the GPS thing. So I have just shown you some pictures. These are some GPS units. This is a Garmin GPS. This is a Trimble. This is a Mayo. This is a compact. People used to use it earlier. This is another thing called SX Blue. This is a Gagan enabled receiver. What exactly is Gagan? We'll just see in the earlier other slide. So we can have just the coordinates from the GPS, that is the latitude, longitude, and the height information from the GPS. Also, we can display our maps also at the back of it. That is what the mobile mapping does. We will see in our subsequent slides regarding this. Okay, and still, if you are very particular regarding the accuracies, GPS gives different type of accuracies. It depends on what type of signal you are using. If you are using a normal CA code, or a L1 code, or L1 plus L2, so different types of, depending on the accuracy we are going to get, depending on the equipment you are going to use, you will get different accuracy. So this is some higher level GPS equipment. So in fact, you can call it a GNSS receivers. So these are nothing but the Trimble. This has a receivers, and this is the antenna of the Trimble receiver. Here, if you see, this is the antenna, and you have the backpack with the equipment. And there is another thing called for the mobile mapping. You can display your maps here, either the vector data, raster data you can display. So this is nothing but a like a receiver, mobile mapping receiver, and which has the SBAS capability also. That is space-based augmentation service. So we should, what is SBAS also we'll try to see in the subsequent slides. So with this in background, we will start the lecture. So what exactly is GPS? So as you know, it is nothing but a network of satellites that continuously transmit coded information, which makes it possible to precisely identify locations on Earth by measuring the distance from the satellite. So basically, you do have satellites in the sky which are launched, and you know the position of the satellites very correctly. From there, you are getting your signals. Once you get some from 4 satellites, you will get your 3D position. Simply stated, the GPS satellites are nothing but a set of clocks in the sky. You have the clocks is there, and you do have atomic clocks in the satellite. So it is very precise. As it is told, it will lose 1 second for every 3000 years. So it is a very precise clock. So why do we require so precise is the question which you may have it in mind. We'll just see why it's. Okay, coming to this, the satellite is kept at a distance, of 20,186.25. If you want to be precise, that is around 20,200. If you know the speed of light is 3 into 10 to the power of 3 into 10 to the power of 8 meters per second, and the time it takes, it is 1 by 15th of a second. So it is very less. So 1 by 15th of the second is the time it takes for the signal to reach from the satellite to the receiver. So you have to, the time is very important concern. That's why you have atomic clocks in the satellite, which loses 1 second in 3000 years, something like that. Okay, coming to the GPS, we use the GPS. In fact, we are mostly referring this to Navstar GPS. What is Navstar? The full form is Navigation, Satellite, Timing and Ranging. That is Navstar. It's an American constellation developed by the US Defense Department. What does it provide? It provides your latitude, longitude, height information, that is for the direct navigation. And the good thing, you have worldwide coverage, 24 hours access, and it has a common coordinate system and accessible both for the civil and military applications. Even though it started with the military purpose, so it is given for the civilian users also. And it is designed to replace the old radio navigation systems. That was the thing what we are trying to refer with respect to the GPS. In fact, very specifically, it is called the Navstar GPS of the American constellation. Okay, what exactly we do have in this signal? If you see the GPS signal, it has something called two carrier waves. That is a L1, which is having a wavelength of 19 centimeters, the L2, which is having a wavelength of 23 centimeters, and two codes, which is having a CA, that is called coarse acquisition on the L1 core carrier, and P or Y code. This is a restricted code, basically used for the defense departments only, and it's an encrypted one. You need to have the decrypting hardware to get that, read that signal. Otherwise, you will not be able to read that, and that is there both on L1 and L2, as well as the satellite orbit message. All the information is there in the signal which we are getting. So if you see this, this is the L1 port, this is the frequency, that is 1575.42 megahertz, difficult to remember. Remember the wavelength, which is approximately equal to 19 centimeters. And there is another frequency called L2, which is having a wavelength of 23 centimeters. And also there is a thing called CA code, which is nothing but 10.23 megahertz, which if you convert into the wavelength, it comes to 293 meters. And the other code is there, P or Y. This is a restricted code, which is having a 10.23 megahertz. So this is almost 10 times better. So if the wavelength of, this is, the CA code is 1.023 megahertz. The P code is 10.23 megahertz, almost 10 times higher. So if you see the convert this frequency, the wavelength comes to 293 meters for the CA code. For the Y code, because it is 10 times better, the wavelength comes to 29.3 meters. So the L1, as I told earlier, it is 19 centimeters, L2 is 23 centimeters. Now, it is nothing but the wavelength which we are using it to measure the distance. In fact, you can remember like this. If you want to measure a distance, and if you are given a big scale like 293 meters for the CA code, you can be able to measure the distance faster, but you will not be able to tell very correctly. So this becomes a slightly thing. If you are not very particular regarding the accuracies for a recreational purpose sort of thing, you can even use a CA code. But if you are particular for your mapping accuracies, then you may need to use the L1 type of receiver, which is nothing but having a wavelength of 19 centimeters. That means you have a scale of 19 centimeters. Once you have a scale of 19 centimeters, you will be able to measure the distance very correctly, but it takes more time. So things you can remember in this way. So hope I'm clear in telling about the GPS signal. So that is not the end. They started with, the Navstar started with this L1, L2. Now it upgraded continuously. Now we are having the L2C signal, also L5 signal, also L1C signal. So we have different type of signals also coming into the picture. Basically, the use of all these signals is, you will be able to, for L2C signal, we do have something called civil moderate and civil long, two distant PRN numbers also is given. Basically, you are able to get the ambiguity resolution will be faster. You are able to get your position faster. So what I wish to tell you, it is not via the signals. They are continuously modifying, improving it to get a better accuracy and even faster also. Okay, coming to the same thing, GPS thing, what exactly we do have some three segments here. One is called a space segment, one is called a user segment, one is called the control segment. In the space segment, we do have the 24 satellites which are being orbiting round the clock, round the year. And in the user segment, we do have the users, both the civilian users and defense users for the aviation, transportation, utility mapping, all these things comes into the user segment. And in the control segment, we do have the monitoring stations and the control station monitoring stations and the control stations. From there, it will be uplinked to the satellite. So basically, it is a complex structure, and it is because the global constellation is quite expensive even to the operate. So that's why India, like IRNSS, the new system which is coming up, it is because it's going to have less cost. So this is what it's going to have the back of the thing. And it's not only the GPS, that is the Navstar, which I was trying to tell up to now. It is not only that, we do have other constellations like GLONASS. It is a Russian thing, which is also having 24 satellites in 3 planes. All we do have 24 satellites available. Again, the accuracy which we are going to get with the GPS, you can be able to get with GLONASS also. But the good thing with if you have multiple constellations, you are able to, in urban areas where you do have an urban canyon effect, you will be able to get your better accuracy once you have multiple constellations like GPS, GLONASS, and the other one, you do have the Galileo. This is the European Union constellation where you have different services. One is called a open access service, which is free air for a mass market but simple positioning. But commercial thing, it is an encrypted, it is a charge based. Like this, you do have different services which is available from European Union Galileo. Soon it will be operational too. Not only that, we do have another thing called, you must have heard thing called Gagan. What exactly is Gagan? Basically, it is a corrected signal what we are going with this, and how it is getting from the full form. If you see, it is nothing but the GPS. Gagan means GPS aided geo augmented navigation. So what we are trying to do in Gagan, it is a station system. It's what it is being implemented by India based on GPS. So we do from GSAT 8, we are getting the corrected signal. If you have a SBAS receiver, you will get the PRN number 120, number 128 also it will be there. So from these things you are getting the corrected signal. So this is nothing but the corrected signal which you are getting. So because of that, your accuracy will be better. Also, we do have a spare one on the GSAT 15 implemented by the ISRO and Airport Authority of India. Basically, the purpose of launching is, if you see this is the Gagan thing. It has a large coverage here. So we do have a control station and the monitoring stations. From the monitoring stations, the errors is being sent to the control station. From the control station, it is sent to the GSAT satellite. From there, you are going to get your signal. To tell you briefly, the Gagan signal, if you have a receiver, the Gagan enabled receiver, in real time, you are going to get your GPS signal, also the corrected signal, that is the Gagan corrected information. So because of that, you will be able to get your accuracy in a much better way, and it will be useful for a lot of applications. That happens to the Gagan. And regarding the Gagan, it is done for the Airports Authority of India. Globally, we do have different services called WAAS, Wide Area Augmentation Service, Europe, IGNOS, Japanese, and for the Indian region, that's why the Gagan thing has come into the picture. Even though it is meant for the Airports Authority of India and the civil aviation, it can be used part of civilian applications also, because you will be able to get better accuracy once your receivers are Gagan enabled. And another thing is called the IRNSS, that is the Indian Regional Navigation Satellite System. As I told you earlier, GPS want to have a constellation of 24 satellites to have the global coverage. It is quite expensive to have the whole constellation. Even for the operating cost will be around 400 million per year. So the whole regional navigation system, what exactly we do have? We do have around 7 satellites. It is an independent regional navigation system, We do have 7 satellite constellations and a ground segment, and coverage area will be around 1000 kilometers beyond Indian territory. And the estimated, and we do have 2 services available. One is called the standard positioning service, that is the SPS, which can give you an accuracy of less than 20 meters, and the another one called restricted service, which can give you an accuracy of 10 meters. So basically this will be serving for the Indian region. So now the question will come whether we should go for it or not. So because it's a regional thing, it's not very costly thing, and at least we do have a guaranteed service all the time. So that's why a lot of regional things are coming up. And we have this 5 satellites has already been launched for that IRNSS, that is IRNS 1E, that was launched on 20th January 2016, and 1F, that is the 6th one, which will be it will be tentatively going to be launched in March, and the last one followed in April of this year. Finally, by mid of this year, all the full constellation will be ready for getting the IRNSS positioning systems. And if you see this, this is how the satellites, there are 3 satellites which are placed in GEO and 4 in GS orbit. These are 1 here, like this, 4 here and this. So this gives for the Indian region thing. So the basic idea to tell you all these things, it is not your accuracies, and you'll be able to faster the area, especially in the urban areas. Your positional accuracy will be better if you have information from more constellations like Navstar, Galileo, GLONASS, and even the Gagan and IRNSS systems. If you are able to use it, we will be able to get better accuracies, especially in the urban areas. And this is very much useful for the urban utility now. Just to say, now we do have a lot of systems. One is GPS, GLONASS, Galileo, and the regional systems and all these things. We use the term called GNSS. Full form will be Global Navigation Satellite System. So it is nothing but a satellite navigation system used to determine the location of the user's receiver anywhere on the earth. As usual, it is available anytime and any weather, which includes all these things. The GPS, Navstar, GLONASS, Galileos, Chinese thing, Vido is there, IRNSS, augmentation services like Gagan and Devas, IGNOS like that. So it is nothing but all the constellations we are able to get the information. We call it a GNSS receiver, GNSS receivers. And coming to this, as I'm telling you, we need to have more constellations and in fact more satellites to get your positional accuracy better and faster. So there are a lot of errors which comes once you have a GPS thing. One can be like ionosphere and tropospheric delays. So just to avoid this, to minimize the effect of ionosphere and tropospheric delays, we do have different signals like L1 and L2. So basically what we are trying to, we have to minimizing the error of the ionosphere once we have 2 signals like L1 and L2. Like this, you do have signal multipath. Like this, if you see in this picture, when you are standing here, this building is obstructing you. So this is not a correct signal. Whereas someone, it will hit the building and return back. So that is also not correct. That is having a multipath error. So that is called the signal multipath. Also receivers also will have clock errors, orbital errors will be there, how many number of satellites are visible, satellite geometry, that is called the PDOP thing. Sometimes intentionally the signal is also degraded. So all these things give some error. So to get a better accuracy, what is the best way we should see for better PDOP? That is PDOP values. Also, if more number of satellites are available, your PDOP will be better, so your accuracy will better. All these things will come into the picture. So now you have to look into the, you have to see what is your objective of the study and what is your accuracy requirement. Accordingly, you have to select the GPS hardware to. Okay, now being told, because so much of errors is there, how to remove that? That is the next question will be. So how to remove that? So you can use the technique called differential GPS to improve the accuracy. So what we do here, we put a receiver, for example, the base receiver at a known place where we know our latitude, longitude and height information correctly. That is that information. And with the help of the satellites, 4 satellites, you are able to get your 3D position. You can see how much of error is there. This you can transmit to your rover in real time. That is called a real-time kinematic survey. So in real time also you can do it, otherwise you can do it in a post-processing survey also. So what exactly we are doing is the differential positioning eliminates the errors in the satellite and receiver clocks, minimize the atmospheric delays, so you are going to get your better accuracy. So if you are, as I told you, there is a thing called code and carrier waves, that is the code means CA, If you are using a code only accuracy, it can range from zero point 0.5 to 0.5 meter to 5 meters. And it depends on what type of area you are standing. If you are standing in a valley, your accuracy will not be very good. But if you are in a plain area, your accuracy will be better. And it depends on if you are standing in an urban area, because of that, you will not be able to get the signals. So this becomes sometimes a problem. So it is always a time and place dependent. But if you use a phase or phase, then you even get millimeter accuracy also possible. That is L1 and L2 type of receiver, even decimeter, maybe 5 millimeter to 10 millimeters accuracy also you will be able to get it. Maybe for plate tectonics, Himalayas rising, something like this. If you are very much interested to have the accuracy of in decimeter accuracy, you will be able to get it, but only you have to use a differential type of receivers. Now, what type of surveying techniques are there? So one is called the stop and go. That is even called a static type of receiver, static type of survey. So basically we are taking in a single point, one place only. That is called a standalone single point positioning, also called stop and go. Yeah, this is for any application where many points close together have to be surveyed. It's a fast, economical, ideal for open areas. Like this, you do have a kinematic. You can put your receiver on the top of a vehicle and keep for the roads, stockpiles like this. Continuously you have to take it, then it is called the kinematic. Otherwise, one place standing you are taking it is called the stop and go. Like this, in the DGPS also you do have the static thing and also rapid static, or called the kinematic. So basically the static you will be using for baselines greater than 20 kilometers, baseline distance between the rover and the base. This basically for the geodetic networks you can use it, and for the large areas. And if you want to do for a baseline up to 20 kilometers, short occupation time, normally used for high production sort of, maybe you want to look at all the electricity poles in the town. So you have to, the thousands of poles, you have to do it. Then you have to go it for something like rapid static sort. So these are the different type of survey techniques available. Also, there are some differential corrections being given as a paid service also, called OmniStar services. This is a paid service where you will get your differential corrections. And what we are trying to tell you, the Gagan, it is also a differential correction, but it's a free service which is given. Even though it's meant for the Airports Authority of India, for the aviation thing, it is given as a free service for the civilians also. But OmniStar is a private service, and it's they do have a different level of services, and it is charged accordingly. Okay, and as I told you, as you've seen earlier, the pictures, even though the GPS receivers were there, we are able to see some maps. But being very small, for example, this is also a small receiver. This display size is very small, maybe 3 inches. So you will not be able to see your maps very clearly. So this becomes a problem. And because it's a smaller thing, the hardware requirements also small, even the cost is less. But these days you are getting some units like this. One is called a UMA pad from the Trimble. They call it a tablet or mobile mapping unit. So this is the, and you do have a 7 inches screen with a good hardware, maybe 80 GB, 100 GB hard disk. You will be able to display your raster as well as the vector data straight here. So this is one type of receiver, again, which has a SBAS capability. SBAS means the Gagan signal which you are getting, the corrected signals is the space-based augmentation system, that is a SBAS signal type of receiver. This is one. Like this, Leica is also a very good one. This is also a mobile mapping unit, Zeno, and this is also a Leica thing. And where you do have an external antenna, even if you want to get your L1 and L2 type of signals, you can be able to get from this type of receiver. The whole thing depends on what is your accuracy requirement. If your accuracy requirement is high, then you have to go for a high-end receivers like this. If it is less sub-meter accuracy, then you can go for something slightly lower end. So the whole thing depends on your skill of your mapping and the study purpose. With this in background, I just told you about what is the GPS, what is the GPS signal, what is the surveying techniques and all these things, how we can use it for the utility mapping. So here comes one thing called the mobile mapping. Basically what I have shown you in the earlier slide here, it is nothing but the mobile mapping units. What we are trying to do here, in the mobile mapping, we are trying to bring fundamental changes in the way geography is utilized, with the ability to interact directly with the world around you. So mobile computing comprises of 3 merging technologies. One is the lightweight hardware, as I have shown you earlier in the earlier slide. So it's a lightweight hardware. Also, you do have the GPS inbuilt in it and a wireless communication, maybe the GSM SIM you can try to put it and you can communicate with the wireless communication. Basically, what type of applications for street sign inventory, power pole management, meter reading, property damage assessment, for things like this, you can try to use the mobile mapping application. So this is also a small picture of the mobile mapping unit. So basically, if you see the mobile mapping softwares also, one can be a desktop software on a systems, on your system, it can be a mobile mapping, desktop GIS. Sometimes it can be on the internet also, you do have the GIS, that is called the internet GIS. This is called the mobile GIS. So you do have different versions, mobile, desktop, and the internet, where you can uh, transfer or synchronize the data from one to the other. That is the basically advent. So earlier when we used to go to the field, we used to carry our maps to the ground, to the field to check where we are standing. We try to reference with respect to the main roads or good landmarks and do it. That was the days earlier, but now better to carry the mobile, carry your vector data to the field, activate your GPS, it will start showing you where you are standing. You can edit, update, create, you can do all the information database creation in the field itself. That is what it is the beauty of the mobile mapping. So basically what led to this mobile mapping? The internet mapping, the satellite mapping, the personal navigation, all these things led to the increasing use of the internet and wireless communication systems in the recent advances in the sensor networks, further enabled to transfer and process data in an efficient manner. As a result, mapping has become mobile and in fact it has become dynamic. That's why we call it the mobile mapping. So hope we are using these maps these days on the mobiles. And the good thing which is coming up for the utility mapping, that is how we can use this technology for the utility mapping. So for the utility mapping, we use the remote sensing data, the high resolution satellite data, as well as the aerial photography, aerial photographs, also this GPS thing, because if you are to capture a lot of point information and sometimes the line information we have which is not available in your other data sources, GPS surveying can be a useful thing. Also, the internet and wireless technologies will come into the picture. So, if as you know, recently the Chennai floods. Basically, we don't have very detailed information of our stormwater drainage network, wastewater thing, drinking water thing. So we need a lot of information, like what is when this pipe has been laid. So basically what happens there, once you have laid the water pipe over the years, the calcination takes place and the pipe diameter comes down because of the water pressure comes down. All these things keeps happening. So we should need a lot of information when the pipe has been laid, what is the type of the pipe, at what depth it has been laid, uh, from where the water is coming from. It's like that, a lot of information is required. So for making informed informed infrastructure decisions requires a lot of diverse information, and it's not a single thing. On a continuous basis we require. And representation and analysis of water related phenomena by GIS facilitates the mapping. So once you have the GPS and the GIS enabled thing, you will be able to manage this in a better. Finally, when you come to this GIS applications that are of particular importance to the water industry professionals include, one is the mapping, why we are doing the mapping, at what scale we are doing the mapping, for how much of area, what are the data, so everything will come. So mapping becomes your main source of information. So for this, the walls, where are the lines, main rise going, and the distribution lines, all the information we can try to collect with this. And that is not the end. After mapping, it has to be used for the monitoring purpose, whether it is serving the purpose, and anything more to be added, how we are going to monitor, monitoring will come. And after monitoring, even the modeling thing will come into the picture. If summer is going to be 3 degrees higher, how much of water requirement will be such sort of thing. And also the maintenance. For example, if you want to change the pipes, which are maybe 70 years old, something like in one go you will be able to get. You have to use all the geospatial technologies for the utility mapping to make it more efficient. So if you see from that point of view, if you see that, what thing we have to see. So GPS has become the best and efficient way of collecting the coordinates and attribute information. And ideal GPS operating conditions include, what is this? One is the low positional dilution of precision. This is called the PDOP. So the PDOP has to be low. That's what it will be very good. So that's why if you have more constellations like Navstar, then GLONASS, also IRNSS, like this, if you have more number of constellations, you will be able to get better positional dilution of precision, especially in the urban areas. Also, there should be good signal strength. There should be little or no multipath. Multipath means the signal, instead of going straight, as I will remind you, the signal takes 1/15th of a second to reach from the satellite to the receiver. So the time has to be very correct. So multipath gives the accuracy will be very less. So little or no signal, magnetic storms, ionosphere, atmospheric, all these things contributes to the error. So whenever we are doing this surveying, we should keep all these points in mind to get a better accuracy. Hope I am clear on this. And the accuracy of the GPS coordinates can be increased by using differential corrections. As I told you, differential corrections means you have to keep one at your base station and another is at the rover. So you can do it in real time. That is called the real-time kinetic service. Receivers, non-real-time kinetic receivers require post-processing. If you don't want it real-time, so you do the survey both at the base and receiver stations. You fix up your time from morning 10 to evening 5, you are going to do the survey. After 5 o'clock, you are going to shut down both the system at the same time, process the data in your office. So that is called the post-processing of the raw data in the office. So this is the thing which will come. Also, the GPS precision varies with respect to the GPS mode. What is the type of equipment? What is the type of antenna you are using? What is your time of occupation? In which area you are staying? If you are in a valley like Dehradun, usually your PDOP slightly will be higher. But if you are in a plain area, your accuracy will be better. So GPS survey cost increases with the accuracy requirements you should have to keep in mind. So a differential GPS that can provide real-time sub-meter horizontal accuracy is suitable if accurate elevations are not necessary. If your elevations are not very much necessary, even a sub-meter accuracy will be sufficient for the utility mapping. So sometimes survey grade RTK GPS equipment that provides centimeter horizontal and vertical accuracy is suitable if accurate elevations information is also required. If you are looking for accurate information, elevation information, you have to use a survey grade RTK GPS equipment, as I had showed you in the earlier slide of the Trimble. I have shown you one of the survey grade RTK GPS receiver. With this in mind, we'll just look into this. What is a mobile mapping unit? Sometimes we call it PDS. What exactly? You can create your data, read your data, GIS data directly in the field. GIS data means you can create your point information, maybe the electricity poles, the line information, the electricity lines, the polygon information, all these things you can create. Otherwise, if you already have the database, you can read it or you can update the attribute. Also, it can be augmented with the wireless technology because this mobile mapping has the wireless communication technology. You can put your GSM SIM to communicate the thing. A small mobile unit looks like this. So you do have a antenna here, you do have a Bluetooth indicator. Sometimes you can synchronize with other type of receivers like SX Blue, which I have shown you, which is a Gagan enabled receiver. You can synchronize with respect to the Bluetooth. You do have the antenna here to get your signal. This is one type of receiver which I'm trying to show you. Also, you do have a camera here. For all the mobile mapping units have a camera so that you can take the not only the point, line, attribute information, also you can take a picture of that so that you can store it in your database. That becomes the important thing. So what is the advantages of this mobile? When you see that mobile mapping unit, there is some mobile GIS software, as I told you. There are some advantages as well as disadvantages. What are the advantages? It can be efficient data creation and updation. You can do it. Ready access to the GIS data in the field itself. Otherwise, we are carrying the paper maps earlier. Now we are able to carry our GIS data straight to the field. Also, you do have the GPS input, so you can create your attribute information, create the vector data in the field itself. Also, you can real-time upload or download through the wired or wireless device. All these things becomes advantages. Disadvantages is there is a processing speed and time becomes a limitation. Being a miniaturization of the hardware, data display is a problem. Even the tablets which I have shown you is having 7 inches display. Even the smaller ones will have around 3 inches display. Also, you do have the data storage limit. All these things becomes a limitation slightly. And mobile mapping softwares, I wanted to just show you 2, 3 things of the mobile mapping softwares. What are the functions? You can display and query the information. You can edit and retrieve the files, import and export the layers, GPS orientation. You can set your waypoints, coordinate systems, camera function is there, and even you have the customization ability. The important thing when you look into the mobile mapping software, look for the what type of vector layers it will support. There is one software called SuperPad which supports the Geo, this is the native format, also shapefile, MIF of MapInfo, DXF, AutoCAD, this sort of files it is going to support into the vector. Into the image, it can support, in the PDA, it can support Mr. SID, ECW, LAN, BMP, GIF, JPEG, PNG, and in the PC version, it will be able to support JPEG 2000. Also, it supports the OGC standard with a user interface. So basically, these are the typical capabilities of the mobile mapping softwares. You just be cautious in case if you are looking into it. So I'm just showing you a screenshot of this. Once you this is SuperPad software as I showed you. This is the thing. Once you this is the GPS button. Once you activate it, you are going to get latitude, longitude, height information, and all these things. And even you can see the PDOP here, which is shown as 2.5. Here the buttons will be. This is for the creating the layers. This is for the layer management. Addition of the layers, this is for the layer management, querying, settings, this is for the GPUs, this is zoom in, zoom out and all these things. In fact, there will be, if you press this button, there will be another window which will come for zoom in, zoom out, previous extent, full extent, this is for the querying, measuring, refresh. All these options, what you find mostly in the GIS, desktop GIS, you will be able to find in the mobile GIS, also mobile GIS softwares. So this is another software developed with the support of ISRO. This is called the QPAD. Here also I request you the same thing. If you see on the top line, you do have this for the opening and creating the layers. This is for the addition of the layers, layer management. This is for the GPS thing. This is for the settings, identify, zoom in, zoom out, then query, previous extent. So, and another thing is once you see here, there is a signal. Once you put your SIM card, you get the network connectivity also. If you want to display your Bowen maps or a Google Earth maps, whatever at the background of it, you will be able to display. Or you want to upload this data to the servers, you will be able to do it. All this this is possible with the help of the mobile mapping softwares. So this is the third one, is the ArcGIS mobile from the S3. So there are a lot of softwares which is available. More or less the functionalities everywhere it is the same, with have some native formats and other things. But more or less all the functions will be available in this mobile mapping softwares. So another thing what we do in the utility mapping, instead of creating all the information in the field straight, it will take more time. Better you take the high resolution satellite data, first create your base map information, copy to the mobile mapping unit, because you can just connect your mobile mapping unit to your desktop to synchronize your data, go to the field, update your attributes. Once you update it, either you transfer it wirelessly, or once you are back, you can update your maps. Instead of doing all the information in the field, this works out easy. I'm just showing you a small study. This is a quick word image of Gurgaon. We just took one sector of this area. For example, this pocket which I'm trying to show you. I'm trying this I try to fit into this screen. That's why it looks small. But if you enlarge it, this looks like this. These are the total how many buildings are available, all the information. You can create your building footprint map. Once you create the building footprint map, you can visit your field later. When we had this data, these are the yellow is the thing which we had the buildings. When we went to field, these are the new buildings which has come up in 1 year, and this blue means these are the buildings which are coming up now, under construction. So like this, you can do your updation in the field. Even you can do this thing for the utilities management also. Like this is for the another area. So total number of 83 are complete, under construction are 26. Like this can be used for so the best way is, instead of creating all the information in the field itself, better we use the high resolution data to create the database, then copy that one to the mobile mapping unit, do the updation in the field. That can be more economical. So now I will just try to show you some slides of the water supply thing for the utility mapping in Dehradun. So this is the Iconos image, and if you see, this is the north of Dehradun, this is the south of the north of Dehradun being the hilly area. We don't have a lot of tube wells. We do have on the southern side a lot of tube wells. This tube well information you can try to capture very clear. Sometimes it is not going to be not visible clearly on the image. you have to get that information from the field using the GPS. That can be a good solution. So these are the locations of the tube wells, overhead tanks. You can see the location of the overhead tanks, which was collected with GPS as well as the satellite data, and you can try to put it on your maps to visualize where the tanks are and where the supply is going, whether it is done efficient way for the whole management you can think of using it. So this is the whole network. So as I told you, this is the northern side and southern side. Now these are the lines, water supply lines. If you see here, usually water supply people use a different type of terminology. There are some surface sources, tube wells. There is something called chambers. Then you do have pump houses, clear water reservoirs, booster stations, then raising mains, distribution mains. This is how their terminology will be. So basically we are trying to locate all the information. For example, you want to locate a wall. So it is not going to be possible on the imagery. You have to get that information from the GPS itself to map that one. So once the whole thing is done, this is how the whole map looks. The earlier, these are the OHT means overhead tanks. You can see the overhead tanks here. So in the earlier slide, I have shown you where the overhead tanks are located all over the city. So for this thing sort of studies, GPS and mobile mapping is very useful. And a small ward here, the Walwala, what type of network is available. You can see here, and you can put it as a surface or even a subsurface. Also, you can try to, for example, some lines may be going underground, at what depth it is going. Such information also you'll be able to map it, and you can see it in a three-dimensional thing. So getting subsurface information, you have to use something called a GPR, ground penetration technique, a small radar, small equipment with which you will be able to estimate, know the location of the pipe underground. So like this, another study for another ward, we just took it. This is one ward called Dharampur, where we do have some 3 tube wells, which gives so many liters. LPM means liters per minute. Tube well number 3 gives 1800 liters per minute, and it is operated 16 hours per day. It comes to 1.73 million liters per day. Means 1800, that is per minute, into 60 gives us per hour, into 16 hours gives the total things 1.73 million liters per day. So like this tube well giving this, the other one 2.4. So now you'll be able to see how much of water is coming from the different tube wells, and how much is the demand and how much is the supply. For the demand supply analysis, it will be useful. And this data is being used here. This is the Dharampur thing. You do have the water supply lines, where the walls are located, where the overhead tanks are located, all the information. This is the information regarding the year of installations, when the pipes has been laid. All the information has been given here, and what is the type of pipe, whether it's an asbestos, PVC, GI, all this information. So it is not only that information of the location, also you need to collect the information regarding all the information regarding the pipelines. This is useful for calculating the head loss, means whether the sufficient pressure is coming or not. So the earlier thing, mostly you have to try to capture with the help of the GPS information. In addition to that, with the satellite data, you can try to find out the block-wise map of the study area, the land use of the study area, the building typology, and how many flows is there, how their water is being stored, all the information. Something you will be able to get from the field, and something you have to get from your questionnaire surveys, something from the satellite data. All these things, information is useful for doing a 24/7 water supply, or if you see that sufficient water pressure should be there. So for demand supply analysis, all these things are useful. And here GPS and mobile mapping will be very useful to make your database more efficient. And as I told you, this is something called GPR, that is called the ground penetrating radar. This is a small equipment, radar equipment, which you are going to, for example, if a pipe is going there, you have to take this equipment there. It will send the signals, and if there is a change in the dielectric constant, it will reflect back. That's how you are able to estimate what is the depth of the pipe at which you are, this thing is there. So there are different type of techniques available for doing all these things. Yeah. Basically, the contrast in the dielectric constant gives you a lot of information regarding this. So even you can go up to 60-meter depth. If it is a low conductivity material is there, if it's a dry sand or granite is there, even you can go up to 60 meters depth also is possible. But for utility sort of thing, you are going to use a high frequency receiver. Maybe you can get up to shallow depth, maybe 0 to 10 meters, where your pipe cables and all these things are there. If you use a 4 gigahertz thing, you can go up to 0 to 4 meters. If you use a 200 megahertz frequency, even you can go to 0 to 9 meters. So basically what you are trying to get, we are going to get the information at what depth the pipes are there. So for this, usually for the utilities, you are going to use this equipment called the GPR, that is ground penetrating radar. I will not cover much. I just wanted to show you some information regarding this. Not only that, also there are a lot of people working on this. For example, NIC, they created large database for good number of cities like Delhi, Mumbai, Chennai. They worked to create the database. So the basic objective is data where. So they want to create the water supply, the electricity network. So basically they try to use a different type of the GPS is very useful. In addition to that, they use the remote sensing data. Also the GPR has been used to get the information of the pipes. Like this, that is another thing. This is a one study which was done by company Hotech. I just took it as a reference to show you. Basically, if you see here, they created a GS implementation is New Delhi Power Limited. That's for the North Delhi Power Limited. They tried to create the whole GS database there. From the electric distribution level, they created the full database. Basically, if you see here, you have the mobile mapping, you have the network analysis, you have the GIS web analysis, there is a SCADA system, SAP, customer relationship management, customer information system. All information has been clubbed to get into the enterprise GIS. And this was the enterprise GIS implement, and DPL earned awards for this one, Geeta Excellence Award and all these things. And even you can just have a look at it if you wish to have more information regarding this. But I wish to highlight that a lot of information has to be collected, and mobile mapping works a lot of useful tool to create a utility information system in this extent. Then not only that, you must have heard this Delhi State Spatial Data Infrastructure. If you have seen it, they try to create the underground, above ground, all the utility information, three-dimensional database on a scale of 1:2000. They have tried to do it, and the data has been shared among the all relevant departments. For example, if somebody was going to dig the line, they should have the information where the pipeline is running. So the pipeline information created by water supply system will be hosted there, and the PWD people will be able to use that data to see that whether any pipes are running. So it will be a very good successful story that Delhi State Spatial Data Infrastructure DSSDI portal. If you wish to have more information, I request you look into their website for details. Like this, I just wanted to show you a small thing. This is a IARS campus thing. We just took the GPS, just walked along the campus, just walked down. Once you do it, you can just get that one into your Bhuvan or Google Earth, wherever you want it. This track log file, you can get it here. But the caution is, with mobile mapping software directly, you will not be able to do conversion from your mobile mapping to the KML, something like that. So in that cases, instead of from the mobile mapping thing, this mobile mapping software, instead on the desktop version, it will have the option. So you can convert from the track log file to a shapefile, from shapefile to KML. There are a lot of options available. So I wish that it's not mobile mapping software, even though it is given for the mobile devices, some additional options will be available in the desktop version. When you purchase that software, that will also work as a useful tool for you. This what I have shown you is for the Windows mobile. So what I have in the earlier slides I have shown you is for the Windows mobile, the SuperPad, the Arc Mobile, ArcGIS Mobile, or the QPad and other things. Like this, there are other softwares available for the Android also. There is SM, and people keep using this one. There are some people are more keep asking how about the Android mobiles. So there are some softwares available for the Android also, for the mobile mapping, the navigation, map viewing and other things.
And other thing is Paparazzi. This is one more thing where you do have the forms also available. You can, it is not only maps, and you do have the forms where you have to fill in all the attributes of all these things. Like this Manu, there was a very big exercise mapping of the neighborhood thing, which was done for during this Kedarnath accident also. Somebody will cover that. That is also made for an Android based application. So finally, just to conclude that GPS is one of the most exciting technology of the decade, especially for the utilities, and it's continuously evolving. It started with L1 signal, L2, L5 is coming, then SBAS is coming. Then you do have third-party providers who can give the differential corrections like Gagan signals, so regional navigation system. So a lot of things, and every day the technology is growing, we can say. And these applications will change the lives and save money. A lot of money has been changed. So basically, the mobile mapping will help managers to manage our natural resources. For example, the water supply people, the engineer, if he wants to, the field staff, they, when they go to the field, so they take the picture of it, they send to the office through the wireless communication, immediately they can take a decision what to be done. So decision can be taken faster. And also the utility companies, basically the water supply, they have the large outside infrastructure and they can manage the resources more efficiently, reducing the consumer costs. Basically their water supply lines from coming from a lot of distance, even sometimes 40-50 kilometers distance also the water supply lines keep coming. They have to manage from where the lines are running, whether in which condition it is there. So a lot of mobile mapping data is going to that mobile mapping attribute information is required to keep the database updated. Finally, just to say, GIS, GPS with GIS applications are so numerous that the possibilities can be limited only by your own imagination. So the applications are, a lot of applications are there. I have tried to show you some applications for the water supply, like the stormwater drainage networks, for this sewer lines, for everything, for all networks, even for the telephone information system. Basically, we try to create an information system with the data collected from the GPS, mobile mapping, remote sensing, all these things. It will become, once it becomes a good information system, you can make it as an enterprise GIS database so that you will be able to know which consumer has paid the money or who has not paid, how to send alert. So all the information in one go. Even you can integrate with this SCADA, a lot of operational applications, even the RDBMS, all this information it is possible. So the applications are, the possibilities can be limited by your own imagination. That's what I wish to say. Thank you.